Okay, suppose you want to find the area between y equals x squared and y equals 8 minus x squared between their intersections. Well, let's see what that looks like. If we go into y equals, and I have x squared and 8 minus x squared, and I hit graph, we're looking at the space in between the two curves. So first thing you want to find are the intersections. To find the intersections, there are two ways to do that. You can actually set these functions equal to each other. So we could go x squared equal to 8 minus x squared, and then solve for x. If we solve for x, we'll get 2x squared equals 8, and so x squared equals 4, so x equals plus or minus 2. Those are the intersections. If you look at the graph and you find the intersection, right here that's x equals negative 2. We can verify that by going second trace, going down to intersect, hitting enter, and then scrolling across the intersection, and we're going to hit enter, 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 and you see it comes out with negative 2. And similarly for the other intersection. So we want to find the area between these curves from negative 2 to 2. So how do we do that? Well, if you're using calculus, what you have to do is you actually want to find the integral from negative 2 to 2 of the top curve minus the bottom curve. Notice the top curve is 8 minus x squared, and the bottom curve is x squared. So the top curve is going to be 8 minus x squared, and the bottom curve is we're subtracting off x squared. So we have 8 minus x squared minus x squared dx. We want the area, and that's why this is an integral. If we perform that integral, if we simplify before we do the integral, we want the integral from negative 2 to 2 of 8 minus 2x squared dx. And so that's the integral we want to find. Okay, so we said we want to integrate, find the area between 8 minus x squared and x squared between negative 2 and 2, and that's the integral from negative 2 to 2 of 8 minus 2x squared dx, because you take the top, which is 8 minus x squared, minus the bottom, which is x squared, and integrate in between the two of them. To figure out this integral, what you have to do is take the antiderivative first of all. So that antiderivative of 8 minus 2x squared becomes 8x minus 2x cubed over 3, and then you're going to evaluate between negative 2 and 2. So you want to evaluate that between negative 2 and 2, and the way to do that is we plug in 2 first, so we'll have 8 times 2 minus 2 times 2 cubed all over 3. So we have that piece, and then minus, now we plug in negative 2. 8 times negative 2 minus 2 times negative 2 cubed all over 3. And if you evaluate that, so you may have to plug it in your calculator to evaluate this, but you get 21 and 1/3. So that's the area between the two curves in between the intersection. Now, on the calculator, you could find the area between negative 2 and 2 underneath 8 minus x squared, and then the area between negative 2 and 2 underneath x squared, and take the difference. Or you can go and you can plot this new function we have, 8 minus 2x squared. So 8 minus 2x squared. It could somehow clear these two up here above. So you just have this one, and then you graph that. It looks like this, and we want the area between negative 2 and 2. This is not the original two functions. This is the composite of those two, the difference of those two functions. So to find the area, we go second trace. We go into integrate, number 7, enter. The lower limit is negative 2, enter. The upper limit is 2, enter. and it's going to give us the area of 21 1/3.